line inclined to both HP and VP or line inclined to both the planes. Suppose when a line is inclined to HP, we will get the true length of the line in inclined position, and that means the front view is the true length of the line when a line is inclined to HP, and the top view will be shown as a reduced length. Similarly, when a line is inclined to the VP, so the true length of the line will be obtained in inclined manner and the reduced length will be obtained as a front view. When a line is inclined at theta with respect to HP and inclined with respect to the VP, phi with respect to the VP, then both the front view, that means the projections, both the projections shall be very smaller than with respect to the true length of the line. Projections means here the front view and top view lengths will be less than, smaller than true length of the line. These views shall also appear to be inclined at an apparent angles with respect to HP. Apparent inclination with respect to HP is denoted with alpha, and apparent inclination with respect to VP is denoted with beta. So here in this condition, when a line is inclined to both HP and VP, so alpha, that means apparent inclination with respect to HP is greater than the theta. So alpha is nothing but apparent inclination with respect to VP, or we can call it as apparent inclination with respect to the front view is always greater than the true inclination with respect to HP. Similarly, apparent inclination with respect to top view, that is beta, is always greater than phi, that is true inclination with respect to VP. So these inclination, the apparent inclination will be greater than the true inclination in case of line inclined to both HP and VP. So here we can see the two conditions, whether, so the first condition is theta plus phi. When theta plus phi is less than 90 degrees, how we will solve the problems? And when theta plus phi is equal to 90 degrees, that means when the projectors are on the same projector, how we will draw the projections. In this condition, so in this position we can learning about these two cases. Some of the important inclinations are theta. So theta is always, we can call it as the true inclination with respect to HP. So this true inclination with respect to HP can be drawn above the reference line or on the reference line. And phi is nothing but here true inclination with respect to the VP. So we can draw below the reference line with respect to the vertical plane. We will draw with respect to the vertical plane. True inclination with respect to VP can be drawn below the reference line. And alpha is nothing but the apparent inclination with respect to front view, or front view inclination with respect to VP, with respect to HP. And beta is nothing but the top view inclination with respect to VP, or we can call it as the apparent inclination with respect to the top view. So here a problem is giving that here a line CD measures 80 mm long, is inclined at an angle of 30 degrees to the HP and 45 degrees to the VP. The point C is 20 mm above HP and 30 mm in front of the VP. Draw the projections, they are asking that. So in these problems, first of all we can draw the reference line. Draw the reference line in series. After drawing the reference line XY, draw the projection of point C and point D. The point C is 20 mm above HP and 30 mm in front of the VP. 20 mm above HP. So take 20 mm above the reference line, draw the front view of point C, and 30 mm below the reference line you can draw the top view of point C as C dash and C point. And now, so they are giving that angle of inclination with respect to HP is 30 degrees. So from C dash, they are giving the inclination line, and from C, they are giving the inclined line with respect to VP is 45 degrees. So from C dash, making an angle of 30 degrees. From C dash making an angle of 30. So you can take 30, and similarly from C making an angle of 45 degrees, we will draw the true length of the line. Draw the true length of the line. So with the length of 80 mm. They are giving that the true length of the line in our problem is 80 mm. And similarly from point C making an angle of 45 degrees, we will draw the true length of the line with the length of 80 mm. And now here I am locating this point as D1 dash, and I am locating here, this one is the D2. So here C1, C dash and D1 dash, C dash and D1 dash, which is equal to CD2, which is equal to 80 mm. They are giving the true length of the line. Now from all the points we will draw the horizontal projection lines. So you can follow the same procedure. From point C dash, from point D2, we will draw the horizontal projection lines. From point C1, C dash also we will draw the horizontal projection line. Now from D1 dash, draw the vertical projection line. Similarly from D2, draw the vertical projection line in upward direction up to C dash horizontal line. So here you will get the two intersecting points. So D1 dash will intersect the C horizontal line at point D1. So D2 vertical line will intersect the C dash horizontal line at D2 dash. Now by using your rounder, take C dash as center, C dash D2 dash as the radii, draw the arc up to D1 dash horizontal line. C center, CD1 as the radii, draw the arc up to D2 horizontal line. Now we will get the intersecting point here. So this point is I am treating as D dash, and this point is I am treating as D. So joining CD. So this is our required top view. So when the line is inclined to both the planes, we will get the projections in inclined manner. That means both the front view and the top view will be obtained in inclined. So C dash and D dash and CD. So after that you can joining D dash and D. So by using your H pencil, 2H pencil, joining D dash and D. So here, coming to the thick lines and thin lines, the true length of the line C1, C dash and D1 dash and CD2 is also thick line, and the front view and the top view, that should be thick line. CD and C dash and D dash, that should be is also in thick line. Now we will give the dimensioning for the problem. So this is our required problem. Now we will give the dimensioning. So this dimension is, they are clearly giving that. So the dimension so the angle with respect to HP is 30 degrees. Angle with respect to the VP, that means with respect to the true length of the line. So CD2, so this angle should be 45 degrees. And also this dimension is also, they are clearly giving that. So you can mention that dimensions also. So this dimension is 20 mm above and 30 mm in front of the VP. And also this dimension is also, they are clearly giving that the true length of the line we can draw in an inclined manner. So this dimension is also 80. And also this dimension is also they are giving that CD2. So this is also 80. So like that we will construct the diagram. So here, so D dash and D1 dash. So this one is, we can call it as the locus of D dash. And this is locus of point C dash. And this is locus of C. And here you will get locus of D. So like that we will draw the diagram. So whenever a line is inclined to one plane, so first of all we will give the preference to the point. So after drawing the point C is 20 mm above HP and 30 mm in front of the VP, and draw the front view and top view of that point. And so they are giving that angle with respect to HP is 30 and angle with respect to VP is 45. So from point C dash making an angle of 30 degrees, we will draw the true length of the line 80 in 30 degrees inclined manner and locate D1 dash. And from point C making an angle of 45 degrees, so we will draw the D2 line. We will draw the D2 line, that is CD2 is equal to 80 mm. So after drawing C1 dash, C dash and D1 dash and CD2 with 80 mm, so from point D1 dash, we will draw a vertical projection line up to C horizontal line. Similarly, from point D2, we will draw a vertical projection line in upward direction up to C dash horizontal line. So locate D2 dash and D1. Now taking C as center, CD1 as the radii, draw the arc up to D horizontal line, D2 horizontal line. Taking C dash as center, D2 C dash, D2 dash as the radii, draw the arc up to D1 dash horizontal line and locate D dash and D, joining CD and C dash and D dash. So we will obtain our required front view and top view. So these are the projections. So like that we will draw the projections of the line whenever a line is inclined to one plane. A line measures 75 mm long. A is 50 mm in front of the VP and 15 mm above HP, and B is 15 mm in front of the VP and above HP. Dimension is they are not giving in the problem. Top view of AB is 50 mm long. Draw and measure the front view and find the true inclinations. That means they are asking that true inclination with respect to HP and also true inclination with respect to VP. That means theta and phi value, and also front view length also they are asking here in the problem. So first of all we will draw the reference line initially. After constructing the reference line, we will give the preference to the point notation here. Point A is 50 mm in front of the VP and 15 mm above HP. So 50 mm in front, you can take 50 mm in front and locate the point A top view as small a, and take 15 mm above and draw the front view of point A, that is A dash and A point. And they are not giving the distance between the projector, but they are giving the another end point position is they are giving that in the problem. B is 15 mm in front of the VP, but they are not giving the distance between the projectors, so that the B point position is we can assuming as a line. So 15 mm in front means, so take 15 mm below the reference line and we will draw the projection of point B as a line. We will draw the projection of point B as a line like that. Now they are giving that a line measures 75 mm long. So they are giving that the true length of the line is 75 mm. And also they are giving the top view of AB is 50 mm long. So where we will get the top view? So below the reference line from point A, if you draw the horizontal line, we will get the top view. So from the top view, we will draw a horizontal line with the length of 50. Suppose they are giving that front view, we will draw from the point A dash, we will draw the horizontal line. But here they are giving the top view of AB, so that we will draw a horizontal line with the length of 50 mm. So I am locating A. So AB2. So AB2 length which is equal to 50 mm here. After drawing AB2, so projecting this AB2 in vertical direction. These are the construction lines. Now with the length of true length 75 mm long. So with the length of 75 mm long, with the length of 75 mm from point A dash, you will cut that incline line and locate point here. So B2. So this point is I am taking as B2 dash. So A dash B2 dash is, so the true inclination with respect to HP, and which shows about the true length of the line. Now from point A also, with the length of 75 mm. So from point A also with the length of 75 mm. So from point A we will draw the arc on the 15 mm horizontal line like that. So we will draw the arc on the horizontal line. So here we can locating this point as B1. After that you can joining AB1. So here AB1 represent about the true inclination, the true length of the line with respect to true inclination with respect to VP here. Now from the points on the incline, from the points on the projection, we will draw the horizontal lines. From all the points, we will draw the horizontal lines. Similarly from B2 dash also we will draw the horizontal line. Now from B2 dash, from B1, we will draw a vertical projection line up to A dash horizontal line and locate that point as B1 dash. Now A dash as the center, A dash as the center, A dash B1 dash as the radii. Draw the arc up to B2 dash horizontal line and locate this point as B dash. So, and similarly A as center, AB2 as the radii, A as center, AB2 as the radii. Draw the arc up to B1 horizontal line and locate here point B. Now we will joining A dash and B dash. So that is our required front view of our diagram. And joining AB line. So here AB is our required top view. So like that we will get the projections. And similarly we can joining B dash and B also. This is our view. So what they are asking here, draw and measure the front view. So we will draw the front view and also top view here. But they are asking that measure the front view. You can measure the length of the front view. So by using your scale, you can measure the length of the front view. So the length of the front view is will get 10, 20, 30, 40, 50, 60, 65 and 67 or 60, 66 mm. So we will get A dash and B dash line length should be 66 mm. And also they are asking that find the true inclinations. So true inclination with respect to HP. That means, so this angle. So this angle should be theta. We can find out this angle. And also true inclination with respect to AB1. So angle with respect to the VP. So this angle should be, we can find out that it should be phi. So we can measure by using your protractor. We will get the angle. So if you measure that angle, we will get above 40. So it will be 44 degrees. I am getting theta is equal to 44 degrees. And also phi value is also can measure. In this position we can measure the angle of AB1. So we will get 28 degrees. Phi is equal to 28 degrees and theta is equal to 44 degrees. Make it in brackets. So which they are asking in our problem. So these are they are asking in our problem. Make it in a bracket. So this is our solution of our problem. Now we will give the dimensioning. So what are the dimensions? They are clearly giving that in our problem. So you can mention all the dimensions. So give the dimensions. So this dimension is 15 mm above HP and 50 mm in front of the VP. This dimension is also 50 and this is 15. So like that we will draw the diagram. And also we will A dash and B2 dash is also 75. We can give that dimension also in inclined manner. So this is 75. So like that we will draw the projections. The midpoint of a straight line AB is 60 mm above HP and 50 mm in front of the VP. The line measures 80 mm long and inclined at an angle of 30 degrees to the HP and 45 degrees to the VP. Draw the projections of the line. So here this problem is different to whenever you can see the previous problem. So this problem is different. So they are giving the midpoint projections and they are asking to draw the projections of the line. So in this problem also, first of all we will draw the reference line and draw the midpoint projection. So midpoint of AB is I am taking as small m. AB is I am taking as m. So midpoint projections first of all we will draw in the diagram. So midpoint m is 60 mm above HP. So m is 60 mm above HP and 50 mm in front of the VP. So point M, capital M is the midpoint of AB here. So M, front view of M is M dash and top view of M is taking as small m. Here they are giving that the line length is 60 mm. Total, so this is the true length of the line. So true length of the line is here to 80 mm and they are giving that angle with respect to HP is 30 and angle with respect to VP is 45. So from point M dash and similarly from point M I will draw the angle with respect to HP and also angle with respect to VP positions. So from point M dash making an angle of 30 degrees. Because they are giving that angle with respect to HP and so draw the true length of the line. So here AB, so M is the midpoint of the line 80, so that so we'll draw the whenever we draw the true length of the line AB, so you can take grade half of 80 mm. That means you can take 40 mm. So 40 mm you can extend 40 mm line with an angle of 30. We can draw the 40 mm line in this direction and also we can extend it in downward direction also another 40. Then will show the total length of the line should be 80 mm. So total length of the line should be 80 mm. Then we will obtain the total length of the line. So taking this one is the A1 dash and taking this one is the B1 dash line. So A1 dash and B1 dash line length, which is equal to the true length of the line, that is equal to 80 mm, and this angle should be here 30 degrees. So you can take M dash and B1 dash 40 and A1 dash and M dash is also you can take 40. So like that, from point M also making an angle of 45 degrees. 45 degrees. So you can draw the true length of the line. In upward direction you can extend 40 mm, in downward also you will draw the 40 mm line. So here you will get, I am taking this one is A2 and this one is point B2. Now from the points on the from the points on the reference line we will draw the horizontal projection lines. Draw the horizontal lines from all the points. Draw the horizontal projection lines. Now from B1 dash, draw a vertical projection line. Draw a vertical projection line up to M horizontal line. Similarly from B2, draw the vertical projection line up to M dash horizontal line. So here I am locating here. So B1 dash, so whenever the projection downward direction, so we'll get B1. So B2 will draw a vertical projection line in upward direction, we will get B2 dash here. Now taking M dash as the center, M dash B2 dash as the radii, draw the arc up to B1 dash horizontal line, and similarly M as center, MB1 as radii, draw the arc up to B2 horizontal line. So here I am locating point B dash and here I am locating small b. Now you will joining M and B. M and B and extended this line up to A2 horizontal line and locating here A. Similarly joining M dash and B dash, joining M dash and B dash and extended this line up to A1 dash horizontal line. So here we will get the point taking this point as A dash. So here A dash and B dash is our required front view and AB is our required top view. So here the true length of the line that should be is also take it as thick line. Like that we will draw the diagram. What they are asking here, so after drawing this one, joining A dash and A, that means A dash and A is one projector and B dash and B is also one projector. So whenever you can joining A dash and A and B dash and B, so the points is on one line, then only the problem is correct. So if the points B dash and B is not in one line, so whenever we will draw the projections, so then we can make some error in the diagram. Okay, we can observe some error. Suppose if the A dash and A and B dash and B is on one line, so we can say that the problem is clearly correct. And so you can give all the dimensions here. This one is 45 degrees. I am writing this one is the locus of B dash and this is locus of A dash, and here locus of A, and this is locus of small b. After that we will give the dimensions. So what are the dimensions they are giving that here? The midpoint projections is they are clearly giving that in our problem. So we'll give that midpoint projections. Midpoint projections is we can mention in our problem. So this one is 60 mm above HP and this is 50 mm in front of the VP. And also they are giving that the true length of the line A dash and B1 dash and A2 and B2 that is equal to 80 mm. So we will draw the problem like that. So whenever the midpoint is giving that, we will draw the projections like that. An 80 mm long line AB is inclined at 30 degrees to the HP and 45 degrees to the VP. The end A is 25 mm above HP and lying in the VP. Draw the projections of the line. So in this problem also we can take the end point projection first of all and we will draw the projections of the line. So first of all we will draw the reference line and draw the projections of point A. After that we will go to the inclined position. So point A is 25 mm above HP and in the VP. In the VP and 25 mm above HP. In the VP means on the reference line we will get a point. And 25 mm above we will get another point. So I am drawing here A dash and in the VP means on the reference line we will get point A. And now they are giving that the true length of the line is here, true length of the line is they are giving that 80 mm. And angle with respect to HP, theta is equal to they are giving that 30 degrees and phi is equal to they are giving that 45 degrees. So from point A making an angle of 45 degrees. I will draw the true length of the line. Similarly from point A making an angle of 30 degrees. Making an angle of 30 degrees from point A dash, we will draw the true length of the line. So the true length of the line should be equal to 80 mm. So just we will draw the true length of the line. And similarly from point A making an angle of 45 degrees, we will draw the true length of the line with the length of 80. So here I am locating the point as, so this point is I am taking B1 dash and this point is I am taking AB2. So AB2 is the true length of the line and also A dash and B1 dash is also true length of the line. Now from the points we will draw the horizontal lines. From all the points we will draw the horizontal lines. Now from B1 dash projected the vertical projection line up to A horizontal line, that means up to the reference line. From B2 we will draw the vertical projection line up to A dash horizontal line and locate here. So B1 dash, so we will get here B1, so here B2 dash. Now A dash as the center, A dash B2 dash as the radii. Draw the arc up to B1 dash horizontal line and A as the center, AB1 as the radii. Draw the arc up to B2 horizontal line. So here we will get a point, take this point as B dash and here we will get a point, take this point as small b. Now we will joining A dash and B dash and also AB. So that is our required, A dash and B dash is our required front view and AB is our required top view. So here the true length of the line is also can drawn in thick line. After that we will give the dimensioning. So this angle is 30 degrees and this angle is 45 degrees. And also this dimension is, they are clearly giving that. And AB2 and A dash and B dash dimension is also they are giving in the problem. So you can mention only one of the dimension. So this is 80. So this is 25 mm above HP. So like that we will draw the projection. So here this one is locus of B dash. And here this one is locus of small b. So like that we will draw the projections. So this is the first case when the theta plus phi is less than 90 degrees. So you can observe here theta is 30 and phi is 45. You can add theta plus phi, so we will get 75, which is less than 90. So theta plus phi is less than 90, we will draw the projections like that. So for finding the true length, we know that the true length is nothing but the shortest distance between the 2 points is also we can call it as the true length of the line. So for finding the true length of the line, so we have two methods is there. So one is rotating line method and trapezoidal method. Second one is the trapezoidal method. So in rotating line method, in rotating line method, we will draw the projections in horizontal manner, which is parallel to the reference line. And in trapezoidal method, we will draw the dimensions of the so by taking the opposite dimensions of the projections, we will construct the trapezoid and we will find out the true length and also true inclinations in case of trapezoidal method. So we will draw so this is about the rotating line and trapezoidal method. Now we will draw the one problem here. They are giving that. So this problem I am drawing in rotating line method and also in trapezoidal method. So they are giving that the distance between the projectors of 2 points A and B is 70 mm. So distance between the projectors is, they are giving that 70 mm, not it is a true length. They are giving the end distance between the projectors A and B is 70 mm. So point A is 10 mm above HP and point A is 10 mm above HP and 15 mm in front of the VP, and point B is 15 mm above HP and 40 mm in front of the VP. What they are asking is here the shortest distance between A and B. So you can find out the shortest distance between the A and B and also true inclinations. So for finding that one, so first of all we will draw the reference line here. After drawing the reference line, we will give the preference to the point A position. So point A is 10 mm above HP and 15 mm in front of the VP. So we will draw that projection first of all, 10 mm above and 15 mm in front. So we will draw the projection of point A. So 10 mm above means we will draw the projection of point A as A dash. 15 mm in front means we will draw the projection of point A as small a. And they are giving that the distance between the projectors is 70 mm. So take 70 mm from the projector A and draw the projection of point B. So point B is, they are clearly giving that 50 mm above HP. So take 50 mm above the reference line and draw the projection of point B, and take 40 mm below the reference line, draw the projection of point B. So here we will get point B dash. So here we will get point small b. Now here you can joining the front view and top view. That means you can joining AB line and also A dash and B dash line. So the reverse of previous method, we can get the rotating line method solution. So now from the points we will draw the horizontal projection lines. Draw the horizontal lines from all the points. Now A dash as center, here you can follow reverse of previous method. A dash as center, A dash B dash as the radii. Draw an arc up to A dash horizontal line. Similarly, A center, AB radii, draw the arc up to A center, AB radii, draw the arc up to A horizontal line. So here I am locating this point as B2 and this point is I am locating as B1 dash. Now from B1 dash draw a vertical projection line up to B horizontal line. Now from B2 we will draw the vertical projection line up to B2 horizontal line. Now we can locating. So here I am locating this one as B2 dash and here I am locating this one as B1. So here AB1 is the true length and also A dash and B2 dash is also the true length. So joining that AB1 and A dash and B2 dash also we can joining. So here A dash and B2 dash and AB1 is our true length of the line. So we can measure that true length of the line because they are asking that measure. So that find the shortest distance between A and B. That means we can measure the true length of the line. So how much we will get? So we can measure. So we will get 1386 mm. So and also AB1 is also will get the same value. Will get the same value. So here what they are asking that here A dash B2 dash that is equal to AB1 which is equal to 86 mm. And also they are asking that angle with respect true inclinations with respect to HP and also VP. So true inclination with respect to HP means A dash and B2 dash inclination. Suppose they are asking that apparent inclinations, so you can measure the angle with respect to A dash and B dash and also AB. Suppose true inclination means you can measure the inclination with respect to A dash and B2 dash and AB1 inclination you can find out. So theta and also this one is phi. So you can measure theta value. So this angle should be will get 28 degrees. Theta is equal to 28 and phi value will get phi value will becomes 17 degrees. So theta is equal to 28 and phi is 17 degrees. So like that we will find out the true length of the line and also true inclinations with respect to HP and VP. After that we will give the dimensioning. So this dimension is 10 mm above HP and 15 mm in front of the VP and B is 50 mm above HP and 40 mm in front of the VP. So like that we will draw the projections. So this is the rotating line method. And coming to the next one is, so same problem we can constructing by using the trapezoidal method. So how we will constructing the same problem by using the trapezoidal method. So in this problem also first of all we will draw the reference line. So we will draw the reference line initially. So after drawing the reference line XY, so draw the projection of point A. Point A is 10 mm above HP and 15 mm in front of the VP. 10 mm above and taking 15 mm in front. Draw the projection of point A. So here A dash. So here point A. And the distance between the projectors is they are giving that how much? So you can take the previous problem. So the distance between the projectors is here 70 mm. So you can take 70 mm distance. And draw the projection of point B. Point B is 50 mm above HP and 40 mm in front of the VP. 50 mm above HP. Above you can take 50 and below you can take, below the reference line you can take 40. So here we will get point B dash, point B, and here we will get point B dash. Now we will joining A dash and B dash and also AB. So joining top view and also front view. So in this projection also we will draw the projections like that. Now from all the points, that means from A dash, first of all I am drawing from A dash, draw the perpendicular line with an angle of 90 degrees. Draw a perpendicular line with an angle of 90 degrees. The dimension of that perpendicular line, you can take opposite dimension of A. So here opposite dimension of A is, so this is 10 and this is 15. So you can take 15 mm. Opposite dimension of A dash is, so you can take 15 mm. Take 15 mm. And so from B dash also we will draw the perpendicular line with an angle of 90 degrees. So you can take from B dash, we will draw the perpendicular line. The length of that perpendicular line is opposite dimension of point B. So here 50 mm above and 40 mm in front. So you can, opposite dimension of point B is 40. So you can take 40 mm. We will draw the perpendicular line. So here I am locating point capital A and B. So here AB line, joining AB line. So that line will show about the true length of the line. So in trapezoidal method, so we will draw the projections from the points of that projections. We will draw the perpendicular lines by taking the opposite dimensions and with an angle of 90 degrees. So this angle should be 90 degrees. And similarly from point A, from top view also we will draw the perpendicular lines from point A with an angle of 90 degrees. And similarly from point B also with an angle of 90. Draw the opposite dimension of point B from point A. So from point A, the opposite dimension of point A is 10 mm. So you can take 10 mm. In the direction of 90 degrees angle, you can take 10 mm. And from point B, you can take the opposite dimension of point B is 50. So you can take 50 mm here. So here I am locating point B and here I am locating point A. Now you will joining AB line. So here this angle should be 90 and this angle should be 90. Now you can extending these lines, join AB line and also small AB line also you can extend it. And so these two lines are intersecting, so this angle should be, you can take it as theta, and joining AB line in front also and joining A dash and B dash line also. So this angle should be, you can take it as phi. So you can measure the angle by using the protractor. In this position we can take and we can measure the angle. So we will get phi is equal to 17 degrees and theta is equal to, you can make in this manner and you can measure the angle. So theta is equal to 28 we will obtain. And also you can measure the length of AB. So the length of AB is, we will get 86 mm. Theta is equal to, we will obtain 27 degrees and phi is equal to, we will obtain 17 degrees. So like that we will obtain the, we will draw the diagram. So after that we will give the dimensioning. So we will give all the dimensions, whatever they are giving in the problem. So this dimension is 10 mm. A is 10 mm above HP and 15 mm in front of the VP. So this is 50 and this is 40. So what is the dimension of A dash and A? A dash and A dimension is opposite dimension of point A, and B dash and B dimension is opposite dimension of B. So this is 40, and here AA dimension is 10 mm and this dimension is, you can take 50. Like that we will draw the projections in case of trapezoidal method. So this is the trapezoidal method. A line AB, so a line AB 70 mm long, that means they are giving the true length of the line is 70 mm, and end L is 10 mm above HP and 15 mm in front of the VP, and its top view and front view measures. So top view and front view measures, top view measures 60 and front view measures 40 mm. Draw the projections of the line and find its inclination with respect to HP and VPM. So in this type of problems also, first of all we will draw the reference line. We will draw the reference line. Draw the reference line initially. So after drawing the reference line XY, so draw the projection of point L. So L is 10 mm above HP. L is 10 mm above HP and 15 mm in front of the VP. In front you can take 15 mm dimension. So point L top view, L of top view is L dash and L of front top view is small l. So they are giving the top view length and front view lengths. So what is the top view length? So the top view length should be, so the top view and front view length. So the front view length should be 40 and the top view length should be 60. So you can draw the front view length and top view length in a horizontal manner. So the front view length is 40 and the top view length is 60. So from point L we will draw the top view length with 60 mm. So here I am locating this one as L dash M1 dash. So L dash and M1 dash is our front view length, and LM2 is our top view length. So that is 60 and this is 40. So now from M1 dash draw the vertical projection line. From M2 also draw the vertical projection line in upward direction. Like that. Now you can take the true length of the line. So they are giving that the true length of the line is 70. So with the true length of the line 70 mm, with the true length of the line 70 mm from point L dash, you can cut this, you can draw the arc on this line. From point L also you will draw the arc on M1 dash vertical line. So here I am getting a point here, so taking this point as M2 dash and taking this point as M1. Now joining LM1 and also joining L dash and M2 dash. So this is the true length of the line. L dash and M2 dash and LM1 should represent about the true length of the line. Now what they are asking that draw the projections. So first of all I am drawing the projections. So for drawing the projections from the points on the line, so we will draw the horizontal lines. Just we will draw the horizontal lines from all the points. From M1 also we will draw the horizontal line. Now taking L dash as center. L dash as center, L dash M1 dash as the radii, L dash M1 dash as radii. Draw the arc on the M2 dash horizontal line. Similarly, L as center, LM2 as the radii. Draw the arc on M1 horizontal line. And locate point here. I am locating here, this one is small m, and here I am locating this one is small m dash. Now you will joining L dash and M dash. So that is our required front view. And similarly you can joining small l and small m. So this is our required top view. So what they are asking in our problem, so L dash and M dash and LM. And also they are asking that inclination with respect to HP. So inclination with respect to HP means, so this angle, so theta, they are asking that, and also inclination with respect to VP. So this inclination should be represented by the phi. So these two they are asking in the problem, so you can identify by using your protractor. So in this direction you can place and you can find now the L dash and M1, M2 dash inclination. So we'll get 31 degrees, theta is equal to 31 degrees. And also LM1 also you can identify. So in this direction we can place in this manner and you can find out the phi. Phi is we will get so 54 degrees. So we'll obtain phi is equal to 54 degrees. So like that we will draw the projections. So this one is also one of the method. So whenever they are giving the front view and top view lens, so we will draw the front view and top view lens as a horizontal lines and we will draw the projections like that. So this is also one type of problem. So many times they are asking this type of problems also in examination. So after that we will give the dimensions. So this is 10 mm above HP and this is 15 mm in front of the VP, and L dash and M1 dash. So this length is they are giving that, and also this length is also they are giving that LM2. So this is 40. This is 60. And also true length of the line is also they are giving that in the problem. So this is 70 mm. So like that we will draw the projections. So here this one is locus of M dash, and here this one is locus of M. Whenever the theta plus phi is equal to 90 degrees, how we will draw the projections? So if the projections of the ends of a line are on the same projector, then we can call it a theta plus phi is equal to 90 degrees. Or you can observe theta is equal to and phi equal to, if theta plus phi is equal to 90 degrees, so we can say that the ends of the line are on same projector. So in this case, how we will draw the projections? So by taking some problems. So the projections of ends of the line PQ are on the same projector. The end P is 10 mm above HP and 15 mm in front of the VP. The end Q is 35 mm above HP and 45 mm in front of the VP. So first of all, so they are asking that to draw the projections of the line. That means we will draw the front view and top view, and also find the true length and also true inclinations. So in this method, so we will draw the reference line. Initially we will draw the reference line. So after drawing the reference line, so we will draw the projection of point P. We will draw the projections on one projector. So P is 10 mm above HP and 15 mm in front of the VP. So draw the projection of point P. So P dash, so here, and this is point P, small p. On the same projector we will draw the projection of point Q also. So point Q is 35 mm above HP. So from the reference line you can take 35 mm distance and draw the projection of point Q as small q dash, and take 45 mm in front means you can take 45 mm below the reference line, 45 mm below the reference line, and draw the projection of point Q, small q. So here we will get q dash and here we will get small q. So make it thick because the projections are on same projector line. Now you can follow. So for finding the true length and true inclinations, so you can use rotating line method or you can use the trapezoidal method, but I am following here trapezoidal method. So from P dash we will draw the perpendicular line with an angle of 90 degrees. Take the opposite dimension of P. What is the opposite dimension of P? Is 15 mm. So we can draw 15 mm in with an angle of 90 degrees, and also from Q dash, the opposite dimension of Q is here. So what is this dimension? Total dimension 45. You can take 45 in this manner, like that. And similarly from point P, so here we will get the point P, and here we will get point Q. So joining PQ, you can draw the projections in only one side in this method. So from Q dash also we will draw the projections. So take the opposite dimension of Q is I am taking 45 in this direction, and we will draw the projection of point Q. So I am taking here point Q, and now we will joining PQ. PQ line. Similarly, from point P also, you can follow the trapezoidal method. From point P, so take the opposite dimension of P is 10 mm. So you can take 10 mm in this direction, and from point Q also, you can take the opposite dimension of Q is here 35. You can take 35 mm and locate. So here capital P, and here capital Q, and now you can joining PQ line. What they are asking here, find the true length and the true inclination. That means you can measure the PQ line length, and also you can find the true inclination. That means true inclination, just you can extend it this line PQ line up to the same generator, and also this PQ line is also extended like that. So at that point, so you can measure this angle should be, and this angle also you can measure. So this angle, what is this angle? So angle with respect to front view. So this angle should be, so this angle should be phi, and this angle should be theta. So you can measure this angle. So first of all, I am measuring the true length of the line here. So true length of the line is, we will get 40 mm, 40 mm or 39 mm. I will get the PQ length should be 39 mm, and angle with respect to HP theta and also phi. So you can measure any one angle, and the opposite angle is, you can get 90 minus theta, will get the value. So I am finding this angle. from this intersecting point. I am finding this angle. So theta is equal to 40 here and phi is equal to here 50 degrees. So like that we will find out the problem. So this is the problem. Whenever when the projectors are on the same projector line, we will draw the projections like that. So here the projector is also thick line and the top view and the PQ lines is also thick line here. So like that we will draw the projections. After that we will draw the dimensions. Draw the dimensions of this problem. This dimension and also this dimension. So this dimension should be 10 mm above HP and 15 mm in front of the VP, and this is 35 mm above HP, and this dimension is they are giving that 45 mm in front of the VP. So what is the dimension of this one? So this dimension is I am taking opposite of Q dash, so that is equal to, so this one is 45 and here opposite dimension of P dash is 15. So here I am taking 10 mm and this dimension is I am taking 35. So when the projections are on the same projector, we will draw the projections like that. So coming to the next problem, so this is also one of the best problem for constructing the projections of the line. Projections, if the projections of the line are on the same projector, so this is also one of the problem. So here if you see that here an 80 mm long line, that means initially they are giving the true length of the line is 80 mm and point P position is they are giving that, and also angle with respect to HP is they are giving that theta is equal to 30 and phi is equal to 60 degrees. So in this problem, for constructing this problem, so here also we will draw the reference line initially. Draw the reference line. So after drawing the reference line, draw the projection of point P. Point P is 10 mm above HP. 10 mm above and 25 mm in front. So we will draw the projection of point P. So here we will get P dash and here we will get small p. And they are giving that angle with respect to HP is 30 and angle with respect to VP is 60. So from point P dash, angle with respect to HP is 30. So you can take 30 and here angle with respect to VP is 60. So you can take 60 degrees angle. And draw the true length of the line with 80 mm in the 60 degrees angle, and in 30 degrees angle we will draw the 80 mm line, true length of the line 80, and in this direction also you can take 80 mm. Take 80 mm with an angle of 30 degrees. So here I am locating this point as Q1 dash, and here I am locating this one as Q2. Now from Q dash, this we will draw the horizontal projection line. Now Q2 also will draw the horizontal projection line. And similarly from P also draw the horizontal projection line. From P dash also draw the horizontal projection line. So they are clearly giving that here theta is 30 and phi is equal to 60. So the problem is, so theta plus phi is here 90 degrees. So the projections are on the same projector line, so that we can extend it the P dash projector like that up to the Q1 dash, and also P projector in downward direction up to Q2 horizontal line, and here we will get the points. So they taking this point is Q dash. So this is our front view and this is our top view. like that. Or you can follow the another procedure is just we will draw the from Q1 dash we will draw the vertical projection line up to P, and from Q2 we will draw the vertical projection line up to P dash. So here you can take this one is the Q2 dash, and this is you can take it as Q1. So you can follow P center PQ1 as the radii, you will draw an arc, so we will get the point like that. Get the point like that. Draw the arc. And similarly P dash as center, P dash Q2 dash as the radii, draw the arc, so we will get the arc in between like that. So P dash and Q dash join, and also PQ also joining, we will get the top view, and also this is our front view. So what they are asking, only the projection, that means front view and top view. So make it thick, and here also make it thick lines. Its total projector should be in thick here. After that we will give the dimensioning. So this angle should be here 30 degrees, and this angle should be here 60 degrees. And the dimensions of P dash and P, and this dimension is also they are clearly giving that in the problem. The true length of P dash and Q1 dash and PQ2 is also they are giving that. So this dimension is 80. So this is 10 mm and this is 25 mm in front of the VP. So like that we will draw the projections. So this is our top view, this is our front view, and this is our top view. PQ is our top view. So when the projections are on the same projector line, so on the same projector we will get both the front view and the top view like that. So these are the some of the problems. When the projectors are on the same projector line, we will draw the projections like that.